Hello and welcome to the Neoscore tutorial on staves and staffs. We're going to be looking through the Neoscore notation that's supplied at neoscore.org. Also as well the example that's supplied with the GitHub repository, and we'll have a look at the API for some of the more advanced functions. First of all, we'll start off with this command. So let's go over to the code, dive straight in. We're going to need to call up some methods. So the first thing that we need to do is from neoscore.core, we're going to need to import Neoscore, or else this thing ain't happening. We also need to have some units and some points of reference in the document as well. So from Neoscore core again, because these are core functions, units, we need to import millimeters. And the next one is points. So from neoscore.core.points, we need to import origin for now. And then because we're using staffs and staves, we need to call that object as well. That's not from core, that is from the Western library, because it's a Western concept to have a stave. And that is in staff, and we'll import staff. Okay, so let's go straight to the example. First of all, we need to set up neoscore.setup, or else it ain't happening. And then the first thing we'll do is we'll just write that staff. So what we need is a position. We need to give it a position, and we're going to position it at the origin. That's at the very origin, the 00xy of the thing that it is attached to, which is the paper in the document. We also need to, well, we don't have to, but it's one of the options we need to give it is a parent. But this way, on this instance, we're not going to assign it a parent. It's just going to sit on the page. And we need to give it a length of 100. And then we need to show it. Rather than render it, we're just going to show it onto the screen. So if I run that script and go over to here, we should see that we have, there you go, a Neoscore staff positioned at origin 00, and it is exactly 100 millimeters long on the page. There you go. Okay. But what happens if you want to make a staff more than 10 centimeters long? What happens if you wanted it a meter long, you know, or 10 meters long? So then we need to make this 10,000 millimeters. It's going to be 10 meters long. But what's going to happen to that? Okay, so let's run that script. As you might suspect, this is going to fall off. There it is. It's going to fall off the end of the page because it doesn't know where the end of the page is. And the last thing we want to be doing is guessing, you know, making one stave to go on the top and then the next one down, calling that something else, calling that something else. So luckily, there is something called flowable containers built into the core of Neoscore that allows these automatically adjusts its contents, such as a stave, to break at the end of lines and to be intelligently placed in sequence whilst maintaining the you know, kind of the linear integrity of the thing that is inside the flowable container. So we're going to need to go and get a flowable container, and it is from core. So neoscore.core.flowable containers, and we need to go and get the object flowable containers. And then we can come down here, and I'm going to make it my flowable, and I'm just going to copy what's over on the on the documentation. So we need to call the object flowable. We need to assign it a position. So again, I'm just going to stick it at the origin. We then need to give it a parent. Well, it's not going to have one. It's just going to go straight to the document. We need a length. So it is 300 millimeters long in the example, and a height. And this is 30 millimeters. Obviously, if you're using a piano score, or if you're using a string quartet or a full orchestra, you're going to need to make the height of this container big enough to fit all your staves in. And so they will be broken all together as it goes from line to line. I'm then going to make my staff. I'm just going to call it. I'm going to call it a name. I'm going to give it an identity. Okay, so my flowable runs. It's got a starting point. Doesn't have a parent. It's got a length and a height, and we got my staff. Let's have a look at that. Okay, and as you would expect, or as you might not expect, being 10,000 millimeters long, it's still a consistent line. That's because we haven't actually put it inside the flowable container. If we go back to the code, we will see here that the parent remains none. We need to put this stuff into our flowable container in order for it to obey the breaks that are calculated within the flow. And also as well, it's a bit silly. Let's just make that 300. Okay, let's run that. Let's see what happens. There you go. You can see now that our 300 length has gone away. It's broken and is following the contours of the margins inside the document here. Okay, so each staff has an associated unit type, which we can use to hang stuff off the staff. So let's just go to the next bit of code that is here, this one with the staff lines and the text. We'll rebuild that in PyCharm. So we've got my flowable, inside which we've stuck my staff, and there's the parent there. And so inside my staff, I'm now going to position some text. We're going to need a text object in order to do that. So from Neoscore and its core, because this is a universal concept, text, and we're going to import a text object. Now I'm going to call it my text, just for now. And then in there, I'm going to instantiate the text object. Now the text object needs a starting position. So instead of origins, I'm going to move it, origin would put it to, if we're assigning it into the my stuff, origin would stick it in the top left-hand corner of the stuff. I'm going to move it along a bit. So now I'm going to need to put in a tuple coordinate, an x and a y that's cleverly packaged as an immutable tuple. So using the example here, it's in millimeters, it says 0. That's going to be all the way to the left. I'm going to stick it at 10 just so we can see it shunt in a little bit. And then that's the x coordinate, and the y coordinate here is in staff units. So my staff has a unit, okay? And a unit is a line on the staff. And we're going to stick it, well, 0 would be on the top because that's the first line. We're going to stick it on the next line down, so that would be 1. So there's the tuple made, so that's the position. We then need to tell it where its parent is. They all follow the same protocol: location, parent, and then specific stuff. And the parent is going to be my staff. So I want this text on my staff, which is inside the flowable container. And then I need to tell it what to write. So in here, I'm just going to write hello world, exclamation mark. Okay, let's have a look at that. And as we will see, there it is. The bottom left-hand anchor on the hello world is positioned 10 millimeters in and 1 staff unit down, which is 1 line. obviously if we went half a unit, where do you think that's going to go? Well, let's have a find out. Okay, so let's go back to the code and continue this. I'm just going to copy and paste this text and stick 2 more in, and I'm going to move this along a little bit. So at the moment this is 10 in. Why don't we move this to 100? And why don't we, the x coordinates, we can make this down to 3, and we can say hello world, how are? And then the next one would be, well, it's 300, starts at 300. Oh, how are? No, sorry about that. How are? It's a 300 length staff, so why don't we stick this at 250 all the way along, and we'll stick it at 5, so that's going to be the one below the 5th line, 6th line down, won't it? How are you doing? Do whatever you want. Question mark. Okay, so let's have a look at that. And as you'd expect, we have hello world, which is 10 in, 1 staff unit down. How are, which is 100, so that's 10 centimeters, 100 millimeters in, and it's on the 3rd line, or the 4th line as it would be. And then this one you doing is 250 millimeters long, broken by the flowable container, and it is you doing, which is anchored on the 6th line down, called number 5, and that would be on the C ledger line. Okay. For this next one, I'm going to just copy all of this lot here, come back to the code, get rid of our flowable, all of that lot, and just we have a setup and a show, and we're going to shove some stuff in the middle there. Here we have 1, 2, 3, 4, 5, 6 staff commands. That's going to present us with 6 staffs on the page. The first one, I'm pretty sure we understand it, so that's at origin, so that's the top left hand corner. There's no parent, and it is 100 millimeters long. We've done that one. The next one opens up with a coordinate, so this is tuple xy coordinate, and we've got 0 there. So 0 is another point. It's nice, clear example. Oh, forgive me, comma. 0 is 0 millimeters. It's 0 units, and it's just a nice clear way of instead of having or units, 0, we have the name here. Again, no parent, 100 millimeters long, but now we're starting to play with some of the optional parameters that we can assign to a staff. In this case, it's line spacing, which is we're assigning it to be 1 millimeter wide. I think the default's about 1.75, something like that. So this one's going to produce a standard staff, 5 lines, which has got spacings of 1 millimeter apart. The next 3 are all positioned at 30, then 45 and 60, so they're coming down in height, all the same length, but they are using a line count. So this first one is going to have 1 line, that's kind of standard percussion stave. Next one's 3, don't know what that is. And the next one's 8, don't know what that could be. But it's pretty interesting that we can start exploring these as creative, open kind of graphical worlds. The last one's pretty interesting as well. So that's positioned within the tuple. Left, X and Y, 0 and 85. No parent. It is 100 millimeters long. And we are sending it a pen. So at the moment, all of these are using a standard pen, which is kind of black, solid line, certain thickness, and it will just call that automatically. But we can tell it to use a different pen, and this pen is an object. So we need to go and get the module and the objects, the class for that. So from Neoscore, pen is core concept, and we're going to go to pen. We can import pen, and while we're at it, we can get pen pattern, because that's another object in there as well. So we're handing over a new pen to this staff, And I know that FF0000 is red. I also know that we can get rid of those doubles and just write FF00 if we wanted to as well. And in that pen, there is another pattern. We are assigning it to pattern, which is a dash. So when I press play on this, we should see all 6 of those staves. There you go. Just zoom in. All 6 of those staves in line. There's a normal one, there's a tight one, single line, triple, 8 lines, and if it's visible in this resolution, a red one made with dashes. Now we can change that if we wished to, because these are different parameters. We could have FF0, that would be a different color, and we can change the dash to a dot, or a dot dash, or a dash dot dot. Let's have a look at that. So here we are. It is almost impossible to see, but that is yellow, and it's dash dot dot, excuse me. So that's the end of these. Let's go to the example that is supplied in the GitHub repository. I'm going to copy everything except the top, the first and the last line, sorry. Just copy that, go into here, into the code. Sorry. So I've gone into the GitHub repository. I've copied everything but the first and the last line, and I'm going to stick that into PyCharm, and I'm going to need to write neoscore.show so we can see it. Okay, so let's just talk through this. What's going on here? So obviously we need the core module, Neoscore, or else nothing will work. We have a flowable so that things can be wrapped around a page. And we also have some points and units here. And we also have some additional modules here and some functions like bar line, brace, chord rest, clef. We're going to be dealing with each one of those in a separate video, so I'll ignore them then for the now. We're just concentrating on staff, and we'll also introduce this notion of a staff group as well, so we can kind of group these things together. There is, of course, tab staff we will be using as well. So we have the Neoscore setup, which of course we have to instantiate every time we want to use Neoscore. We have a fixed length variable here, which we're declaring at the start. There is a flowable, which is starting not at origin, but from the left-hand side, 50 millimeters in, and 0 on the 0 from above. So that is the y-axis. No parent. It is of the variable length, and it is 70 millimeters deep or high. We also have set up a staff group so that we can communicate between all of the staffs, because what we have here is 1, 2, 3, 4 staffs set up. This one's going into the origin of flowable, so it's going to be in the top left-hand corner of flowable. It is the collective length of 2000 millimeters, and it belongs to the group. Okay, the group, staff group. It has a clef and a key signature and a time signature, and it looks like it has a note that is there. We'll go on to all of these very soon. The second one is pretty much the same, except it is starting not at origin, but 15 millimeters down from the top. It has a base clef and the same key signature and the same time signature of 3 plus 3 plus 2 over 8. And staff 3 is starting 30 millimeters down from the top, still part of the group, and it has a tab clef. So this is a tab staff rather than an ordinary staff. And then we staff 4 is a normal staff, and that's starting 50 millimeters down from the top. And this one has a single line count, so has an optional property, and the clef is going to be a percussion one there. The next thing that we've done is we have collected all of those staffs together in a list, called that staves. We've put a system line across all of the staves. There is a brace that will bracket all of those staves, and there is a bar line at X position 30 millimeters across all of those staves as well, and then it is getting shown. So let's have a look at what happens there. Okay, so now we can see, if we zoom out, we have 2 meters worth of flowable container containing 2 meters worth of these staffs. At the top you can see that we've got the 4 staffs, and they're all linked with a system line and all braced together, and they all have these individual properties within them, the key signature and the time signature. And there is, at, what did we say, 30 millimeters in, there is a stave, a bar line crossing them all. Okay, so let's have a look at the API, because that will then, what the API does is shows us all of the setup parameters that we need, which are here, and explanations of them then. So it explains what the first creation argument is, which is the position, and also then the parent, what that does, the length, you know, all of those parameters there, what the line spacing is. But up here we can also see them as well. So here's position, it is a point definition, or it is then we have the parent, which is optional, but we fill it in anyway just to make life easy. Length is a unit, the group. We have line spacing, here we go, it is pre-declared as default 1.75 millimeters, and the line count is pre-declared as 5. But it's these extra bits down here that I find particularly interesting. So as it's a class, it needs to be created with all of these arguments, or certainly needs to be created with these 3 all the time. But at the same time, there is added functions to it as well. So for instance, clefs, if we call an object, a staff object, and then dot clefs, it will present us with a list of all the clefs in that staff ordered by their relative X position. So let's just quickly have a look at that. Okay, so we come back to our code. It's getting dark here. We'll get back to our code and we can have a look at staff 4. Staff 4 has a clef. We can see that here. So if we make some space just underneath staff 4, and we call the clefs function for staff 4, it should give us a list, or it should return a list of all of the clefs that are on there. So let's have a look at this. So clef list for staff 4, let's make it a nice clear variable. That says 5, so that's not very clear. Clef list staff 4. We need to go to the staff 4 object, which I've called staff 4, and then we put this dot, and it offers us up all of these options that are there. So let's have a look at clefs. So at the moment, that's just returned that list into that variable clef list staff 4. Now if we print it, just so that we can see what's going on today, obviously you can use it somewhere else in the script if you need to. I'm just going to comment out that so we're only interested in what's going on down in this section here. So if I was to run that script, now we should see that we have a list. We know it's a list because it's got these square brackets, and it gives us a unit. So this is the exposition of a clef. Now the clef is saying that it is a clef object, and it's located at this point in the memory. We don't need to worry about that. If we wanted to find out a little bit more about that clef, we can actually target down even further. So for instance, instead of it being staff4.clefs, actually what we can do is go to the next function in the API, which is active clefs at, and we need to declare, or we need to send it a position. So let's have a look at the active clefs at position 0. It will return the clef at a given position, at that position. So if we go back into the code and input here, we put active clef at, and we need to declare a position, so at 0 millimeters. So whatever is happening at 0 millimeters, what the clef active is on staff4, it is going to print that off for us. So let's just quickly run that. There it is. It's no need. It's only coming back with the clef. Now then, this is an object. This is an object itself. So that becomes very interesting, because as staff objects have functions, clef objects will also have functions as well. So what we could do then is kind of get a little bit, refine it more. So what is the clef type? So what we've got here is, in this variable clef list staff4, we are filling it with a list, or the single clef that is active at a particular measurement. Then we are going to print that clef list staff4 and its, not just it, but its particular clef type. So let's just see what's going on there then. So that's presented us with quite a lot of information. It tells you here what the clef name is. It tells you what the staff position is, which is coming back as a staff position function. So again, we could drill down even further by calling that in this list and getting to know some of the details in there. We also have middle C staff position, and we'll have a look at that in a minute as well. Okay, so let's just go back to the API for one last one, because we can call the key signatures. It'll give us a list of those. It'll call the time signatures, give us a list with their relative X positions, and also the active key signature at, which is an object, and we could probably then define what that active key signature is. In fact, why don't we just do that anyway? Okay, so let's go back into scene. So instead of making this staff4 active clef at, what we will do is we'll call it active key signature at the beginning. Now this is then, we can probably call it something like key signature type. In fact, we can just put this in. This came up automatically. So in clef list, that variable, we are filling it with on staff4 an additional function, which is what is the active key signature at a particular point, which is 0. Then we're going to print that, but not only that, we're going to enhance it by actually it telling us what the key signature type is. So let's have a look here. Ooh. Let's try it at 10, because it might not have operated at that point. No, it's returning a non-type key signature type. Well, don't know what I've done there. Let's take this out and let's just see. Okay, so of course there is none, because we're looking at a percussion stave. We need to go to the treble clef, which is on staff 1. And then we can put the key signature type. Duh, it's getting late in the day, you can tell it's dark. If we were to run that, let's have a look at this. What do we get? Hooray! Key signature type is C flat major. If we go up to the top here, key signature type for staff 1, key signature type is C flat major. Okay. One last function, go back to the API. One last function is to have a look at middle C at position. So this will give you will find the y-axis staff position of middle C at a given point. Obviously, that's going to depend on the clef definition of the stave, because if it's a bass clef, and we can have a look at that in different ways, if it's a bass clef, it's going to come out as a different position. So let's go back to this clef list staff 1. What we need to do is we need to have a look at, let me flick it over for you. Instead of active key, we are going to middle C. Oh, we're going to put in middle C at, and into there. There won't be a key signature type. It's just going to return a coordinate, which will be a Y coordinate, which you'd expect to be a staff unit. So starting at the top at 0, come all the way down the 5. The 5th one is going to be underneath. It's going to be the ledger line there. Let's just quickly change this then to staff 2, because of course that is a bass clef. And let's see what we get there. We would expect that to be staff unit -1, which is the next one above, because Y comes from top to down. So if we need to move up, it's a minus figure. Okay, that's that.